All right, guys. So we are done with all the top-down parsers. We have seen LL1, and in the last class we have seen that the recursive descent parser. Brute force parser is not that much important. Brute force parsers are actually used in natural language processing. Those are nothing but actually trying to find out the string, just exploring all the possibilities. Okay. You can easily implement brute force parser using logical languages like Prolog. Those kind of languages is very easy to implement brute force parsers. Today we'll start bottom-up parsers. Okay, and the very first bottom-up parser we are going to encounter, that is called operator precedence parser. Operator precedence parser is a special kind of parser. Okay, so let's talk about the bottom-up parser and where we stand. So it is something like this. So we have parsers are broadly categorized to two broad categories. This is my parser. It is divided to two broad categories. Number one is TDP or top-down parsers, and we are done with this. Now we have another broad categories, which is nothing but BUP or bottom-up parsers. Bottom-up parsers are also called SR parsers. S means shift and R means reduce. The another name of shift is nothing but push. Another name of reduce is nothing but pop. So can you tell me one commonality between all the bottom-up parsers? Just looking at these two words. What is the commonality between all the bottom-up parsers? Just looking at these two words. What can you say?
Uses a stack.
Is as a stack, because push and pop both are operations in stack. So remember, all the bottom-up parsers must use stack. So that is a commonality between all the bottom-up parsers. All right. So bottom-up parsers are also subdivided to two broad categories. First one is called, which we are going to cover today, operator precedence parser, and another one is LR parsers. We are going to deal much more details on LR parsers later, but right now we are going to talk about the operator precedence parser. Operator precedence parser is very special. In a sense, it is the only parser can handle the ambiguous grammar, but there is a catch. What is the catch? Yes, it can handle ambiguous grammar with the help of a table called operator relational table. Or sometimes we also use operator relational graph. So remember, it can use ambiguous grammar, that is true, but with the help of this. So actually what happened, whenever it use operator relational table, it breaks away from this ambiguity. using this. So you are right actually. Ankur said that they are actually falsely advertising or touting they can use ambiguous grammar at the very beginning class. That is true. It is a kind of touting or it is a kind of advertising that they, yes, we can handle ambiguous grammar, but actually they cannot handle ambiguous grammar. Or in the parser there are some ambiguous grammar, but whenever there are ambiguity happening, it breaks away that ambiguity. In the case of ambiguity, it breaks away using that operator relational table or operator relational grammar. So is it clear to you guys? So this is the catch. So remember. All right? Do you have any question you can ask?
একটু আবার বলে ভালো তো স্যার।
So it can handle ambiguous grammar. You are right that it can handle ambiguous grammar, but what is the catch? The catch is operator with the help of operator relational table or operator relational graph. So using operator relational table or graph, it breaks away this ambiguity. So there is no longer ambiguity when you use side by side the ambiguous grammar and the table, or the ambiguous grammar or the graph. So you are right in a sense that, so actually it is not handling the ambiguous grammar because you are breaking away from the ambiguity using that table or graph. So it is a falsely touting or it is a falsely advertising that it is handle ambiguity. True, but this is the catch. Okay. But before talking about operator precedence grammar, there is a special kind of operator precedence parser. There is a special kind of grammar which is called operator precedence grammar. So the thing is, operator precedence parser, operator precedence parser can handle only operator precedence grammar. From the next onwards, we are going to call it OPG, operator precedence grammar, and we call this parser as OP, operator OPP. So OPP use a special type of grammar which is nothing but operator precedence grammar. Now what is OPG? It is a big question. It's $1 million question. What is the specialty about OPG? So OPG has two specialties. Number one, no two variables can be placed side by side. Number one. Number two, no epsilon should be in graph. So these are the two rules. Do you agree with me or not? No two variables can be placed side by side. No epsilon should be in the graph. Is there a problem?
Yes, sir.
Okay, so it is pretty clear. So let's have some examples and try to find out those are OPG or not. So let's give these examples. So let's try this. So let's try this. So let's have this. Let's assume S derives S A B or S A derives A or A, B derives B or is this grammar sample? Is this grammar OPG?
No, sir.
Why it is not OPG?
SAB variable তিনটা পাশাপাশি।
Variable তিনটা পাশাপাশি. So it's a problem. So this rule has some problem. But other rules are all right. So how can
Yes,
is it?
sir.
So it is not OPG. Simple. So can we convert this grammar to OPG? Can we convert this grammar to OPG?
I believe so, sir.
You believe so? So it is pretty simple. So the Problem is, if we somehow can eliminate this A, this middle A with some sort of terminals, then what happen? Then no two variables would be side by side. Am I right or not?
Exactly, sir.
Now we know the expression of A. So if we put, we still don't know whether we can, it is possible or not. But that is the strategy. If we can eliminate the middle variable A with some sort of terminals or some mixture of terminals and variables, so that no longer two variables are side by side, then we are done. There is no problem. So we are trying to do that now. So instead of A, if we put first this one, then what would be the grammar? S A or B, and we have to also put this one. So if we put this one, it would become S A B and S. Am I right or not? Now this one is done. There is no problem with this. There is no problem with this. But again, there is a problem. A and B are placed side by side. So what can we do?
B এর
Now-
জায়গায় আমরা B
Talk about the strategy. If we again replace this A, still we always get AB. We always get
Yeah,
AB.
okay.
So we cannot replace this A with B, A with A again, A with
So we
A
tried B.
again. So we tried B. So if we try B, then what happened? Let's try another step. S derives S A B B, and we have also need to put this part as well. So it would become S A, then B. We are done. Then actually what happened? We have also S A B. Then we have S. Then A is nothing but A or A, and B is nothing but B or. So we are done. Got it? So now it becomes OPG. Do you agree with me or not?
Yes, sir.
It becomes OPG. So this is how we can convert some, not all, some non-OPG to OPG. So that is the one catch. That is one possibility. Now, how about epsilon? If there is epsilon there, is it possible? So let's take this example. S derives, let's say A or S. A derives A or epsilon. Is it OPG?
না স্যার এপসাইলন আছে স্যার
It is not OPG because we have epsilon. Can we convert this grammar to OPG? There is epsilon there, so it is not OPG. But can we convert this grammar to OPG?
I believe we can try.
We can try. So how? What would be my strategy? Do you know how to convert a grammar to canonical form? Can you remember? Converting a grammar to canonical form. What is that called? What is those steps? What is that algorithm called? What is this form called? Canonical form. In finite automata. And Samira, what is that process? Oh, you people terminate the, you people have not, I did not cover that last semester because we terminated earlier. Am I right?
I think we missed it, yeah.
Okay, we missed it. So that process is called Chomsky normal form. Chomsky normal form. But other people who did the finite automata under, let's forget about under me previous semester than the last semester, or the people do it much before. What is Chomsky normal form?
স্যার সাবির স্যার didn't cover Chomsky normal form.
আচ্ছা যাই হোক আমরা এটা না বলি। আচ্ছা Chomsky normal form is actually converting any grammar to canonical form. It is called Chomsky normal form. Who is Chomsky? Chomsky is a very famous linguist and computer scientist, and one of the Very famous guy. He is actually involved in lot of natural language processing and other stuffs, and he is also very famous linguist as well. Basically, he is a linguist, but he has lot of actually contribution in the computer, especially in the grammar. So he has actually proved that all the automata, like we have four types of automata: finite automata, then we have actually context, we have finite automata, then we have push down automata, then we have actually linear bounded automata, and finally we have actually Turing machine. This four genre of automata can be also represented by a grammar equivalent, and he come up with a classification which is called uh, type 0, type 1, type 2, type 3, this way. Okay, so and he has also invented a procedure to converting this, which is actually nothing but Chomsky normal form. Basically, Chomsky normal form is nothing but reducing, I should say not reducing, I should say eliminating the epsilons from the grammar. So that is actually the core part of Chomsky normal form. But you can eliminate all this epsilon. But if S derives, the start symbol derives to nothing. That means something like this. If S can derive to start can derive to epsilon. If this is the case, then you can never apply Chomsky normal form. Still, there will be always epsilon at the start symbol.
Oh,
So
okay, sir.
remember this one. So for example, I can talk a little bit about that one. Let's say S derives A, B, C. A is nothing but A or epsilon. B is nothing but BB or epsilon. C is nothing but CC or epsilon. So what happens if you put instead of A here epsilon, instead of B here epsilon, and instead of
Yes, sir.
C here epsilon, then it becomes a big
Yes.
epsilon. It
Yes,
becomes
sir.
a big epsilon. In that case, if start symbol directly derived to epsilon, you cannot actually eliminate that epsilon because it is a part of start symbol. Otherwise, all the other epsilon moves you can eliminate using Chomsky normal form. Then that grammar would become canonical form. Okay. So we do not go to much details about Chomsky normal form, but here we are going to talk about little bit about how can we eliminate the epsilon. So the algorithm is very simple. Here A derives to epsilon. So what you are going to do? You are going to write, you are going to take all the appearance of right hand side with A, you will write it with epsilon, with A without putting epsilon, and you write it with putting epsilon. So what would be the case? It is something like this. So S derives A or S, and A derives A or epsilon. So here is a problem. There is epsilon. Am I right? Now what you are going to do?
Yes.
You are going to take all the appearance on the right hand side which involves A, except this one. So this one has appearance of A. So you are going to write this one same. So S derives A. Then you are going to put instead of A epsilon. So what you get? A. S. Now you can remove this epsilon. So you can now remove this epsilon. Now you get your answer. Did you get it? So this is the catch. This is funny, am I right?
Yes,
Now
sir.
it becomes without epsilon. So let's try another one. This is the Chomsky normal form.
স্যার এখানে এ ভ্যারিয়েবলটা তো দরকার ছিল না।
আছে এই যে উপরে একটা এ
ও,
আছে।
হ্যাঁ।
ওকে স্যার, জি স্যার। কারণ it is a good question, Samira. Am I right? You are Samira who asked me the question.
Yes,
Okay, so
yes.
the thing is, you are just replacing the epsilon, not all the replacement of A. You are not going to replace that one. Am I right or not? You are only discarding the epsilon. So you have to have the A over there.
Yeah.
Right?
Okay. Yeah.
Simple. But you are right. If there is no A over here, A just derived directly to epsilon, then you can discard this one. Then you can discard this one, then you can also discard there also. Did you get it?
Yes, sir. Yeah. I
So
got
the
it.
thing is, it is a good question. She asked this thing. She said, sir, how about this? she asked that, sir, if it is something like this, S derives A or S, and A derives directly to epsilon, then yes, same process. We are trying to find out the appearance of A on the right hand side. It is here. Then what happened? We have to write directly.
Sure,
Then we
Jay.
are going to put A. Then we are going to discard epsilon. So we are going to discard that one. Then the final process is there is no term of A, we have to discard this as well. This is the case.
Yeah.
You are right.
Yeah.
That is the thing. Yes. Yeah, you are right. All right. So this is the Chomsky normal form. So let's take another grammar and try to convert it to OPG. So let's take S derives A, AB, AB, or S. A derives AA, B derives BB. All right. So this is the case. So this grammar is not OPG. Am I right? This grammar is not OPG. Am I right?
Yes, sir.
Because it is breaking rule number 1 and 2
And
both.
2.
To both. 1 because there are variables side by
Variable.
side, and number 2 because there are epsilon. So let's try to fix the number 1 first. This one first. So how can I fix that one? Which one I should replace? If you replace A, you always get AB. So it will not bring anything special.
Yeah,
But
so
we
we
can-
replace B.
Okay, if we replace B, then what happened? Then it is wonderful. Then what happened? S derives A, will write BB, and then we are going to write epsilon, so it will become AS. Fantastic. So now it becomes like this. AA, epsilon, and B derives BB, epsilon. So we are done with rule number 1. Am I right? We are done with rule number 1. There is no problem with rule number 1 because no two variables are side by side. But still we have problem with rule number 2. So how can we fix that rule number 2? Using Chomsky normal form.
Yeah.
Chomsky normal form. So what we are going to do? So A can directly derive to epsilon and B can directly derive to epsilon. So we have to discuss this two. So where A appears, it appears here and here. Where B appears, B also appears here. So what we are going to do is derives, we are writing as it is. Then we are going to put epsilon. So it will become A, B, B. Done. Then AA, then S. Now A derives, we can discard this epsilon. Now B also has BB or epsilon. We again apply Chomsky normal form. So if we apply again this rule, then what we get? S derives AA, BB. Then we are going to write without putting epsilon. So it would become AA, B, then again AB, B, and AB, then AA, then S, then we can discard it. We are done. Did you get it? So now it becomes OPG. Did you get the point? Is there any question for us? Guys, did you get it?
হ্যাঁ স্যার বুঝেছি স্যার জাস্ট
Okay,
কয়েকটা
okay.
এক্সাম্পল দেখলে একটু মাথায় আসবে আর কি better
Good,
হবে।
good, very good. So this is the case.
স্যার অ্যাপসাইলনটা কি আমরা জাস্ট এ ক্যাপিটাল এ স্মল লেটার বি আর ক্যাপিটাল বি এটাতেই পুট করছি, স্মল এ ক্যাপিটাল এ এটাতে পুট করছি না?
দুটোতেই পুট করছি। এই যে এবি, AB. If we put here B epsilon, we get AB.
ওকে
We get AB. সবগুলোতে করতে হবে। এখানে যদি if in this case I put epsilon, it becomes A capital AB. A capital AB. If we put here epsilon, we get AB. Is it AB? AB? AB is there. Is it clear or not? Tell me, please.
Yes, sir.
Okay.
হ্যাঁ স্যার
Okay, so let's talk about now we are done with OPG. Now let's talk about the operator precedence parser, OPP. OPP is also like that. It has a stack. It has a stack.
স্যার একটা কোশ্চেন আছে
অবশ্যই
স্যার ওই যে এর সাথে যে অ্যাপসাইলনটা আছে ওইটা রিমুভ করার জন্য স্মল এ ক্যাপিটাল এ একটা আছে না সো শুধু এ স্মল লেটার এ হবে না
Oh, yeah. Right. Thank you. Huh. Right. Wonderful. I was made mistake. Thank you. For this. Am I right? Yes. Good.
Yes.
Fantastic. Right. You are absolutely right. Thank you. So let's talk about operator precedence parser. So this is the stack. At the bottom of the stack, we will consider there is a dollar sign. So it is denoting the end of the. It is denoting the end of the stack. Again, we have a buffer. We know that IP buffer. We have IP buffer, and at the end of buffer, we also consider a dollar, which denotes the end of the buffer. We also have the algorithm, which is nothing but OPP, and we also have a table called operator OPP table. And do you know how they are implemented? So schematic diagram of all the parser are same. This is the schematic diagram. All right. Done. And we know that the terminating condition. What is the terminating condition? When dollar meets dollar, we are going to say successful. Same thing. No difference. Same schematic diagram. All right. Do you have any question you can ask?
নো স্যার
No, sir. Okay. তাহলে আমরা let's talk about the operator precedence table. How can we come up with operator precedence table? Let's assume I have given you this one. Let's assume I have given you this one. And it is very familiar grammar to you. You got this question in quiz as well. E derives E plus E or E star E or ID. Is this grammar OPG?
Yes, sir.
It is OPG. Is this grammar ambiguous?
Yes, sir.
What is the reason behind ambiguity here?
Associativity.
The associativity আছে আর precedence ও mention করা নাই।
Associativity and precedence, both.
Yep.
Now, if we want to use this grammar, in operator precedence parser, what we need to do? What we need to do? Tell me. The answer is pretty simple. We have to break this ambiguity. Am I right?
Okay.
We have to break this ambiguity. So we have to define. You have to define associativity and precedence
Level.
in order to use the grammar in OPP. Now, the catch is we don't know associativity and precedence. Am I right or not? So how can we actually fix that one?
Awesome.
How can you fix that one? We don't know any accessibility or precedence because the grammar is actually ambiguous. It has accessibility and precedence problems. So how can we fix that one? We are going to create our own table. Did you get it?
Yes, sir.
So we
Yes,
are going
sir.
to create our own table. We are going to give a precedence of the operators. So that is our catch. So based on your precedence, remember, based on your precedence, based on your precedence, based on your precedence, the parsing would be happen. Parsing would be happen. So for example, let's say Samira. Another one is Ankur. Samira in her table gave plus more precedence than star. And Ankur in his table gave more precedence to star than plus. Then what happened? If we try to if we try to find out the result of this expression, 4 plus 3 star 2, what would be Ankur's result? What would be Ankur's result?
10, sir. 10.
Your result would be the 10. And what would be Samira's result? It would be 40.
14, sir.
Yes, sir.
So that's, if there is ambiguous grammar you want to use, then you have to come up with your own operator precedence table. You have to fix your accessibility. So in this case, which one we can take? We already know a accessibility rule in our algebra, which is nothing but, what is that called?
Bodmas.
Badmas. অনেক আবার প্যাম দাসও বলে। ঠিক আছে, এটা বলে। So it is nothing but bracket or parenthesis and all the things are same. Exponential, division, multiplication, addition, subtraction. এটাকে ব্যাডমাস কেন বলে? আমরা কি ডিভিশন, we do division before multiplication or we did division after multiplication? Which one?
Sir, division before.
Division before, sir.
তো এটা তো আচ্ছা, যাই হোক। Okay, so this is the case. So how can we do that one? So we can do this one. So let's draw a table. So my leftmost column, all the terminals. So I have ID plus star plus, and we have some special one. You know that at the end we always consider a dollar. So we have another one, dollar. And again we have here ID star plus. So you can consider this is the left side. You can consider this one is the right side. Okay, guys. Now, ID and ID, what would be the associated? ID and ID, what would be the associated? Or the precedence?
They're equal.
Equal, sir.
Okay, so what type of grammar is this? It is operator precedence grammar. Did you remember?
Yes, sir.
In operator precedence grammar, two variables can never be side by side. So means E and E is possible or not? Can
No,
you
sir.
ever have this kind of transitional state, E and E? Am
No,
I right? Possible? No. So we can never get ID and ID side by side. We restricted this possibility using operator precedence grammar. Am I right or not?
Yes, sir.
So it would never happen. If it is happening, it is error. Did you get it? Did you get it?
Yes, sir.
Now,
sir.
ID and
একবার বলবেন
star.
স্যার?
So it is the operator precedence grammar. So we can never allow two variables side by side. Am I right? One, you can get ID and ID. You can get ID and ID if and only if two variables, that is E, side by side. But we restrict that one. We can never allow this one. So we can never get ID and ID side by side. Am I right? It is not possible. So it is undefined. Somehow if we get ID and ID side by side, it means it's error. It's a blank entry or something. It is error. You have to handle that error. Is it clear?
Yes, sir.
Yes, sir.
Now, ID and star, which one is greater?
Star.
Star.
No, ID. No, ID.
ID.
Oh,
ID.
sir.
Okay.
I did.
Okay.
So what happened? Let's go to our previous example. For example, if we want to parse this, let's say using Ankur's one, then what happened? E derives E. So see, all are logic, nothing else. E plus E, then E derives E star E. Then this one becomes 2. This one becomes 3. This one becomes 4. So it is actually whenever we parse, you can remember E derives E plus E, then this E derives E star E, then this one becomes 4, this one becomes 3, this one becomes 2, if we apply this. Ankur's associativity. Then what happened? It is a bottom-up parser. Am I right? We are going from
Yes, sir.
bottom to up. It's a bottom-up parser. So at the very beginning, which one we need to derive? Which one we need to reduce? Not derive. Which one we need to reduce? We need to reduce 2, 3, and 4. Am I right?
Yes, sir.
So that means this ID part needs to be done at the very beginning. Am I right?
Yes, sir.
So ID should have higher precedence than any other operator. Okay, guys. Now, star and ID. So it means this arrow means nothing but on the left side we have ID, and on the right side we have a star. Which one has higher precedence? ID. So that's why you put arrow this way. Did you get it?
Yes, sir.
Now let's go to second row. Star and ID. Which one would have higher precedence?
ID.
We know ID always has higher precedence, but in this time, on my left side there is a star, and on my right side there is ID. So which side I should do?
Less than.
What would be
Sir.
so we have to then less than symbol.
Less
So
than.
it would be like this. Done. Now star and star. It is associativity problem. If we have two multiplication operations side by side, which one I need to do first? So it is associativity problem. So which one I need to do first? According to Badmas,
Left, sir. Left one.
left, because star are left associativity. So we are going to do this. Then star and plus. What would be the associativity?
Sir.
Star has
Star.
higher precedence,
Star.
so this would be like this.
Greater
Star
than.
and dollar also has the least precedence. ID has the highest precedence, and dollar has the least precedence. Now let's go to plus and ID. What would be the case?
Sir. Less than. Less than, sir.
Okay. Plus and star, it would be also less. Plus and plus, what would be associativity?
Sir. Greater.
Left associativity. So-
Left or right. Greater.
Right. And this one is also less.
Less than.
And dollar has
Agreed.
least precedence than any other operator. So smaller things. And finally, when we get dollar and dollar, we are going to guess. So this is the table we are done. Did you get it?
Yes, sir.
Now using this table, we are going to parse. So don't worry. We are done with the major task of creating table. Now we are going to parse.
তো স্যার আমরা এখানে আমরা আগে টেবিলটা ডিফাইন করে দেব।
Speak in English. Speak in English.
Sorry, we will define this table.
We will define this table. If
Okay.
the grammar is ambiguous, then what happened? We don't know the precedence and the associativity. We are going to create according to our wish this table. But if the grammar is not ambiguous, then what happened? In that grammar itself has the information of precedence and the associativity. Am I right or not?
Yes, sir.
We know if there is a grammar, we know that what is the, if that grammar is not ambiguous, we know how can we find out the operator precedence and the associativity. We did lot of problems like that. Am I right?
Yes, sir.
So catch is, if the grammar is ambiguous, we have to come up with our own table. We are going to create our own table. On the other hand, if the grammar is given in such a way which is not ambiguous, that means it is unambiguous, then we can easily find out the operator precedence and the associative. Then directly there is a one-to-one mapping from the grammar to table. So if the grammar is ambiguous, we will come up with our own table. If the grammar is not ambiguous, unambiguous, then we can create our table. Simple. Is it clear?
Yes, sir.
Okay.
So if the grammar is not ambiguous, then it can automatically create the table.
Yeah, you don't have any other option because grammar is going to dictate to you how to create table. Am I right?
Grammar is going to?
Grammar is going to dictate you how to create table. Am I right or not?
Oh.
Did you get the point? Both no boglan. Instead of this grammar, let's say, instead of giving this grammar, if I give this form, let's say, instead of giving this grammar, if I give this form, এই জিনিসটা আপনারা সবাই ভুল করে. All of you make mistake. Many times I gave unambiguous grammar, still you come up with your own table. That is the problem. So let's look this way. If the grammar is like this, E derives E plus E or E star E or ID. This grammar is ambiguous. Am I right?
Yes, sir.
This grammar is ambiguous. So you have to come up with your own table. On the other hand, if I don't give this grammar, if I give this, it derives E plus T or T. T derives T star M or M derives ID. Equivalent grammar. Am I right?
Yes, sir.
Equivalent grammar, same grammar. No problem. Active string. They are going to generate the same string, but this grammar is not ambiguous. Am I right?
Yes, sir.
So can you come up with your own table? This grammar will dictate to create table. Dictate to table. Create table. Dictate to create table. So then you don't have any option. You have to map this grammar to the table. On the other hand, if the grammar is ambiguous, then you can create your own table. Is this clear to you guys?
Yes, sir.
So this is the case. That time, whenever you are creating your own table, then you can fix whether I should put plus higher precedence than star, or I should put star higher precedence than plus. It is your choice. But in this case, you don't have any choice because star has higher precedence than plus. It is actually printed there. Did you
Sir.
get it? Yes.
গ্রামারটা কি অ্যাম্বিগিয়াস নাকি নট অ্যাম্বিগিয়াস এটা তো আমাদের বলে দিতে হবে অ্যাজ এ রাইট?
একটা গ্রামার দেখলে আপনার তো বোঝা উচিত যে এটা অ্যাম্বিগুয়াস নাকি আনঅ্যাম্বিগুয়াস।
মানে পার্সার তো এটা নিজে বুঝবে না, রাইট?
পার্সার কখনোই বুঝবেন না। পার্সার তো বুঝলে তো কাজ হয়ে যেত।
মানে অ্যালগরিদম তো নাই।
No, there is no algorithm. So you have to. So whenever I give you a grammar, you have to somehow find out that it is ambiguous or not. If it is ambiguous, that means there is a problem with associativity and the precedence. Then you have to create your own precedence and associativity. And if the grammar is not ambiguous, unambiguous, then you don't have any option. Sometimes, for those, remember, sometimes it might happen in a grammar, some operators are ambiguous, some operators are not ambiguous. Then what you are going to do? Then what you are going to do? Tell me.
তাহলেও বলবো অ্যাম্বিগিয়াস।
Ambiguous, but how can you create the table then? Some operators are precedence problem, some operators does not have precedence problem. How can you create the table?
শিওর না স্যার?
Sir, we'll have to see from you.
So, if some operators are ambiguous, for those ambiguous operators, you are going to create your own precedence and associativity. But some operators might not be ambiguous. Then you don't have any option. You have to follow the steps of the grammar. It is going to be printed there. What is the precedence and the associativity of the grammar? Did you get it?
Yes,
জি
sir.
স্যার।
কথা না বলে বুঝি না। Instead of this grammar, if I give this, let's say this, E derives E plus E or T T derives T star M or M derives ID. So this is also the equivalent grammar. Am I right?
Yes, sir.
Yes, sir.
This is also equivalent grammar, but here plus is ambiguous, star is not ambiguous. So how can you fix that problem? See, star is deeper side than the plus, so it is apparent star has higher precedence than plus, and it is also left associative, so star is left star has higher precedence than star, but plus is not clear, so you can do ID. Yes, plus and plus, it is not defined, so you can take anyone. You can take plus greater than plus, or then you have option of this. Did you get it? So it's a
Yes,
good
sir.
question. So remember this thing. Porika wala, if I give this kind of problem, then it's a mess. Okay. So we are done with the table. Now let's try to parse some string. How can we parse some string? Now, before going to parsing, let's talk about little more. So always remember this leftmost. You can fix this. Leftmost column, it is nothing but entry in the stack. This stack entry. And topmost row, it is nothing but buffer entry. Did you get it? So topmost row is nothing but buffer, leftmost row is nothing but stack. So let's try to parse this. Let's assume I have given ID plus ID star ID. At the end, there is a dollar. So how can I parse this? Okay. Did you get it?
So will it be in the buffer or stack?
It is in the buffer. This is the input. Input is always in the buffer. Input is always in the buffer. This is the buffer. This is the buffer part.
বাফার বলতে কি বোঝাচ্ছেন স্যার?
এটা তো একদম buffer. What is buffer?
বেসিক্যালি মেমোরির মধ্যে কোন একটা লোকেশনে আছে।
No. It is the buffer. The very first class question. Initially, all those things inside the buffer.
Or input stream.
Input stream, yes, input stream or buffer. All the input stream initially in the buffer. এখান থেকে we are going to take one by one character. Did you remember the tokenizer step?
Yes, sir.
So
Yes.
this is the input stream.
sir.
Input stream is initially in the buffer, and currently my look ahead is pointing to this ID. Is it clear?
Yes, sir.
Okay. And it is my stack. Initially it is empty. At the end of the stack, there is a dollar. So this is my stack. All right, guys. Now start. My stack has what? What is my stack?
Dollar.
Stack, dollar.
Dollar. And what is my look ahead?
ID.
So in the stack, I have dollar. In the buffer, I have currently pointing to ID. So let's go to table. Stack, dollar. And my buffer is pointing to ID. Which one is bigger?
ID.
ID.
ID. So if the buffer is bigger, we are going to push. We are going to push. So ID is going to be push. Did you get it?
Yes, sir.
Now my stack. What is the current entry in the stack? What is the topmost entry in the stack?
ID.
ID. And what is buffer is pointing?
Plus.
Plus. So let's go back here. Now stack is pointing to ID and buffer is pointing to star. Which one is bigger?
So it will be plus.
Buffer
ID
is
and
pointing to plus, sir.
Buffer is pointing to plus. And stack is pointing to ID. Which one is
Yes.
bigger?
ID is bigger.
So then pop. So pop from the stack. Now let's go back. What is the rule for ID? ID can only derive to E. So this ID is now going to derive to. Did you get the point?
আরেকবার বলেন স্যার।
So rule 1, stack greater than buffer pop. Number 2, stack smaller than buffer push. Is it clear to you guys?
Yes, sir.
Now let's go back again. What is the stack now? What is the topmost entry in the stack? Dollar. What is the current look ahead in buffer?
Plus.
Plus.
So let's go back. Stack is dollar and buffer is plus. So which one is bigger?
Plus.
So what we are going to do? Stack is smaller than buffer. Push. So push plus. Now stack has plus and buffer has ID.
ID.
So stack is plus and buffer is ID. Which one is bigger?
ID is bigger.
ID is bigger.
Is
Now
bigger.
it means stack is smaller than buffer. What we are going to do? Push. Now stack has ID and buffer has star. Stack has ID and buffer has star. Which one is bigger?
ID.
ID. So what we are going to do? Stack is greater than buffer. We are going to pop. So ID, there is only one rule. ID can derive to E. So this would become 2. Now, what is the stack entry? Plus. And what is the buffer entry? Star. So stack is plus, buffer is star. Which one is bigger?
Star.
Star is bigger. So buffer entry is bigger. So what we are going to do?
Push.
Push. So push. Now, stack entry is star and buffer entry is ID. Stack entry is star, buffer entry is ID. Which one is bigger?
ID.
ID.
ID. So buffer entry is bigger. So buffer entry is bigger. What we are going to do?
Push.
Push. So push. Now, we're going there. Now, stack entry is ID. Buffer entry is dollar. Stack entry is ID. Buffer entry is dollar. What we are going to do? ID is greater.
ID
What we are
is
going to
bigger.
ID is bigger, so we are going to pop. So we are going to pop this ID. There is only one rule. This ID can become E. It becomes E. Now we have stack star and buffer dollar. Stack is star and buffer is dollar. Which one is bigger? Dollar star is bigger. So stack is bigger than buffer. What we are going to do?
Pop.
Pop. Now see, we have E and E as it is operator grammar which has a star in between. So there is only one entry on the right hand side, E star, which becomes E. So it would become E. Now stack entry is plus and buffer entry is dollar. Stack entry is plus, buffer entry is dollar. Which one is bigger? Plus. So we are going to, stack entry is bigger, we are going to pop. Pop. Now we have this one
Dollar
becomes
per dollar.
dollar. This whole part become E, and we have star. We have plus and E. So it will become, there is only one rule, E plus E is equal to E. Then finally we get dollar. Do you have any questions?
So when does the reduction take place?
এই যে রুলটা লেখাই আছে। রিডাকশন হচ্ছে যখনই পপ হবে there is a reduction. এখানে পপ হওয়া মানে রিডাকশন। যখনই একটা পপ হবে it is going to find out possible reduction.
Understood.
Okay, sir. Now, what is the problem with operator precedence parser? Can you tell me? There is a problem with this parser. What is that? If you go to this table, how many entries are there?
16.
16. So how many terminals are there? How many terminals
Sweet.
are there?
Four. Dollar,
Four,
including
actually.
$4.
Including 4. So 4 terminals, we have 16 entries. If there are 10 terminals, how many entries should be there?
100, sir. 100. N squared.
100, because we are creating a table, 2D table.
Yes, sir.
2D
N squared
table,
basic.
2D table mesh grid, so it would become 2D mesh grid, that's why it would become square. So it is something like this, O into terminal square. So this is the complexity of this table. It is a big problem because number one, if there are 100 terminals or 100 operators, how many entries would be in the table?
10,000.
100 square.
Oh, 1,000
100
square.
square.
That's messed up.
100. If there are 1,000, let's take 100. If there are 100 operators, then it will be
10,000.
100 square.
Yes, sir.
So 10,000. It's a big number, and you are continuously actually getting entries from the table. So it is not a very efficient way. Somehow, if you can reduce the size of this table, that would be wonderful. Am I right?
Yes, sir.
So that's why that is another concept we are using. Yes.
Graphs.
So yes, graph. We know that any simple. Yeah, wonderful. Can you tell me how can we reduce these entries? We know that graph can be represented 3 ways. What are the 3 ways? Come on.
Adjacency list.
First one is adjacency matrix. It is nothing but adjacency matrix. We are converting this adjacency matrix to adjacency list.
Yes,
Good. So this matrix is going to be, it is nothing but adjacency matrix.
Yes, sir.
It is nothing but adjacency matrix. So we are going to convert this adjacency matrix to adjacency list. Adjacency list. So how can we convert that one? So let's consider, let's name this left side nodes as F and this one as G. This is right side, this is buffer, this is G. This is left side, this is stack, it is F. So we have FID, GID. We have F star, G star. Then we have F plus, G plus. Then we have F dollar, G dollar. Now we are trying to find out the relation between these nodes. Okay, so what is the relation? Tell me. FID and GID, there is no relation. FID and G star, there is a relation. What is the relation? Which one is bigger?
Your ID is big.
ID.
ID is bigger. So
If
FID is greater than G star. So we can say this is nothing but this kind of relation. So we are going to put this. Did you get it? Now FID to
yes, sir.
FID and G plus, it is also like this. Then FID and G dollar, it is also like this. Now let's go to F star. Let's go to F star. F star and GID, which one is bigger?
GID.
So it should be like this. So F star and GID. It is something like this. So we are going to write this kind of this. Now F star and G star, which one is bigger? This one is bigger. Okay. Now F star, G plus, G dollar. Now let's go to next one. F plus and GID. Which one is bigger? So remember, so simple. Just remember this one. F plus and GID. Which one is bigger? GID is bigger. Then the arrow would be like this. And F plus and G plus. Which one is bigger? This one is bigger. Then the arrow would be like this. Did you get it?
Yes, sir.
Then F plus and G star. Which one is bigger? This one is bigger. So F plus and G plus. Which one is bigger? Then finally, this one. Let's go to F dollar. F dollar and GID. So it is like this.
Lowest precedence, so everything is
Yes, of course.
pointing towards.
Pointing towards it. And finally, it. So we have convert adjacency matrix to adjacency list. Done. Now what? Now we are converting this one. Actually, not completely adjacency list. Some information of adjacency list. সবগুলা প্রয়োজন নাই, কিছু ইনফরমেশন পেলে গেল। এখন what we are going to do using this graph, we are trying to find out longest common path. Now, what is the longest common path from FID?
Sir, what do you mean by common?
We are going to see. Longest path. What is the longest path from FID? You can go from FID to G star. Then you can go to. You can go
F plus. F. You can go to F plus.
G star to F plus. Then F plus 2, you can go to G dollar. We have done with ID star plus. So we have done with FID. We have done with G star. We have done with
A plus থেকে G plus এ যেতে পারবে।
Y plus to G plus. Thank you. খুব ভালো observation. G plus, then G dollar. খুব সুন্দর observation. আমাদের পরিশ্রম কমে গেল। তাহলে আমার মোটামুটি এইগুলো হয়ে গেল। বাকি থাকে হচ্ছে এই কয়েকটা। এই কয়েকটা কিভাবে করব? দেখেন, G স্টারের সাথে F স্টারের একটা রিলেশন আছে, আর F স্টার ক্যান ডাইরেক্টলি গো টু G স্টার। তাহলে আমার পুরো আবার লংগেস্ট কমন পাথ আই ডু নট নিড টু রাইট ফর অল দ্য নোডস। তো আমি এখান থেকে F স্টার বের করে এটা থেকে GID করে দিতে পারি। বুঝা গেল কমন কেন বলেছি?
আচ্ছা,
এটা মাই ইনভেনশন, ইট ইজ মাই ইনভেনশন।
আচ্ছা,
কারণ আমরা জানি যদি এখান থেকে এটা যদি লংগেস্ট পাথ হয় তাহলে ডেফিনেটলি এখান থেকে এটা longest path according to algorithm, cut and paste algorithm. Can you remember cut and paste algorithm? If here to here this is longest path, then if you can join here to here another longest path, then definitely this to this is also longest path according to cut and paste algorithm. Done?
Yes, sir. মনে আছে স্যার।
So মনে আছে স্যার, GID F star is done. F ডলারটা কার সাথে রিলেট করা যায়? F dollar can relate to G plus. So then we are done. All are covered. Now find out the longest path.
Sir,
Now-
when did you find this trick, sir? Oh, sorry, sir, like a tough question. But when
Just-
did you find this trick?
Now I know that this one and this one is the longest path. Then if I find longest path from this to this, then definitely this to this. It is simple intuition and logic, nothing else.
That's very cool, sir.
That's
I
cool.
just think.
So FID,
স্যার জি প্লাস থেকে জি ডলার যাওয়ার তো কোনো প্যাচ নেই।
G plus থেকে G dollar যাওয়ার কোনো এই আছে, G plus to F dollar.
মানে স্যার জি ডলারের যাওয়ার তো প্যাচ নেই, জি ডলারের কথা বলছিলাম।
Oh, good. You're right. G plus is right. Yes, thank you. Yes, right. Simple. Now it is all right? F plus থেকে G dollar যাওয়া আছে. Thank you. Good observation. Now FID has 1, 2, 3, 4, 5. Then G star has 4. Then F star has 5. GID has 6. Then F plus has
3.
3. Then G plus has 2. Then G
G plus
dollar
1. G plus should have 1, right, sir?
না 1 2 আমি দুইটা করে কাউন্ট করতেছি 1 2 3 4 5 এভাবে count
Oh,
করছি।
okay, sir.
নিজের নোটটাও কাউন্ট করছি।
Okay.
Then G dollar is 1, F dollar is 5. So this is the information we get. All right, guys. Now,
Okay,
if you
sir.
convert this to table, what you get? If you convert this to table, what you get?
স্যার ক্যামেরাটি একটু ঠিক করবেন স্যার।
হ্যাঁ
স্যার ব্লাড দেখা যাচ্ছে প্রচুর।
ক্যামেরার প্রবলেম এটা নেটের প্রবলেম। Now, is it all right?
Yes, sir.
Let's finish it. So, if we convert this to table, what we get? We get this. F G ID star plus dollar. FID has 5, GID has 6, F plus F star has 5, G star has 4, F plus has 3, G dollar has 1. Now we know that F is nothing but stack and G is nothing but buffer. So again the same rules. Number 1, stack greater than buffer, pop. Number 2, buffer greater than stack. Now it will be homework using table parse the all right, so this is the end of today's class. If you have any query, you can ask.
Sir, the class was nice, so I don't have any questions regarding the concepts.
Okay.
But one question I had was, why do we prefer for an OPP? Like, why do we need it? Like,
Yeah, so actually the thing is, okay, see, it's a good question. It's a historical question. First, do you know which parser has been developed, which bottom-up parser has been developed first?
which one, sir?
LR0.
Okay, sir.
Then it is actually invented by Knuth, LR0. Knuth is a famous computer scientist, Donald Knuth. Then he has developed it more to SLR parser. Then he developed it to SLR parser.
Okay.
Then people come with with more beautiful concept, then they can invented more powerful parsers like LLR0, LLR1, CLR1. Then they increase the look ahead. They come up with CLR2, CLR3. So the whole process of developing something is actually evolution. You can never stop. You always need to search better, 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 better. There is no ending of better, uh, better search. There is no ending for searching for better things. So same way, I don't know who has invented operator precedence grammar, but I assume some people has come up with this concept and some scholars find it very useful. Then they actually also put it in your textbook. They said, yes, it is also possible to parse using this kind of concept. So it is nothing but a very academic discussion. Okay, it is an iterative process. It is an evolution process. We cannot, for example, now right now many people says that today's mathematicians are very developed. Can you deny Newton, Isaac Newton? No, you cannot deny him. Or can you deny Archimedes? Or can you deny Pythagoras and their contribution? No. This is whole iterative process and evolution process. You cannot deny anything. The same way some people might come up with this concept, operator precedence parsers and operator precedence grammar. Those are beautiful. That's why we study this. Okay, guys? Any more question?
Okay, sir. Thank you.
So you
Sir,
have Ankur, you have exam at 7:30. Please remember.
Yes, sir. I remember, sir.
Yes.
I'll join the class.
Sir, I had a question regarding the homework, sir.
Mhm.
So, using which table and which string?
So this is the table, and string is also given. You know the string. This is the string. ID plus ID star ID. This is the table, and this is the string. Just write down these two, but because it might take time to upload. So this is the string, this is the table. Why don't you draw your own table, try to come up with your own table, then create your own graph, then just check whether this is correct or not. Then string parse them. Okay? So this is actually after midterm issues. So remember, you have a midterm on Tuesday.
Right.
Alright guys?
All right.
Should we
Okay,
leave
sir.
today? Should we leave today?
Sure, sir.
Okay, we can leave today. Thank you very much.
Thank you, sir.
Wonderful midterm. Before that one, just take your attendance. Attendance.
Okay, sir.
Bye guys. Take care. Have a nice midterm.
See you soon, sir. Thank you. Okay, bye.